And welcome to my web map video demonstration. My name is Alex and I'm excited to show you the process I use to create my New England inspector map. The purpose of this project was to test the viability of my skills in creating a map that shows the locations of company inspectors in relation to any given inspection location. My coworker will be losing her access to a mapping resource which she uses to assign cases to inspectors and visualize coverage demand, unfortunately. I wanted to develop a map that offers some of those services that she'll no longer have access to. I'll start with a run through of how I use this map. If I wanted to know which inspector to assign a case, I would search in the address bar. So for example, let's search here. 325 Valley Street in Providence, Rhode Island. I'll hit enter, the down arrow to select, hit enter again, which zooms me into the location that is to be inspected. When zooming out, I can see a little pop-up here. I'll zoom out one more time to see all of the surrounding exposures here. I can see that when I click here that K. Gonzalez is the inspector, and I would choose to then offer the case to this inspector. I can also see some nearby water exposures and fire stations, which supplements my knowledge of the types of exposures I would expect this inspector to report on. Now, to describe the sources and methods I use to create this map. The first source I took in creation of my base map was the state boundaries file located on the ArcGIS online resource here. It is a zip shape file which contains the US 50 states and DC, which is convenient. I actually selected only the New England region just to hone in and make sure that I wasn't covering too much of a data set that would be able to be handled using tiles. So I also calculated a buffer, which was 50 miles around the states, in order to select the inspectors outside of the region directly, because they are able to travel into the region when requested. The next source of data was my roads data set, which came from the USGS National Transport data set. The other resource I have is the water bodies data sets, which is actually a combination of three, the US detailed water bodies, which are major lakes, reservoirs, rivers, lagoons, and estuaries, specifically on land. I also needed the coast water exposures, so I found a oceans data set, which is provided by the Flanders Marine Institute. And finally, the Canadian government also has water exposures above, north of the United States in the form of a water file, major lakes and river polygons. All three of these datasets were subjected to a selection process, which distilled the features, and then they were intersected with the New England buffer and then merged together into one dataset, and it looks something like this. The important shared characteristic of these datasets were the name features, because in order to be useful, they needed defined boundaries in the form of polygons, and then the which could then be isolated, which could then allow for the isolation of a name near to an address. And it also allowed for labeling of those features in the web map. Finally, the fire stations dataset was again also hosted on ArcGIS Online, and this was the these were fire stations in the United States at any location where fires are stationed or based out of, which is convenient when you want to know the kinds of fire station exposures. This data set looks something like this. You can see it's quite comprehensive and thorough. All right, so the major important feature of this map was that it didn't require GeoServer to run on the host in order to display the map. This was deliberate since I wanted my coworkers to be able to use the map without relying on the server. So I actually created tiles in order to make them very aesthetically pleasing. I used Tilemill in order to do this, which is a free and open source software. These custom features were chosen because of their relevance or protective exposures. And also the reason why I wanted to do it this way was because, oh my gosh, I'm totally screwing up. The fire station's dataset was clipped using the New England buffer, as you saw in the previous QGIS. Now, the pre-processing steps and tools were mostly done in QGIS for practice using free and open source software. The base map layers were also designed using Tilemill, which of course these features were chosen because of their relevance as hazardous or protective exposures, and also the Tilemill, another source of free and open source software, allows for the customizing it's a very intuitive way to customize the visibility and labeling properties at certain zoom levels. So I wanted to be able to start out with a very simple map, and then when zooming in, I wanted to be able to see the labels of certain features, and I also wanted the roads to become visible at that point. So an important feature of the map is that it doesn't require GeoServer to run on the host in order to display the map, and this was deliberate since I wanted my coworkers to be able to use the map without relying on a server. As such, the tiles were then exported from Tilemill into a folder, which New England base map folder, which looks something like this. And these files, PNG files, are, like I said, tiles of images that are hosted. In this case, they are hosted together and pulled from the Pass Explorer, which looks like this. So then they're referenced in the code at these specific locations. Although I am hosting on Pass, I would hope that after winning the admiration of my coworker and my boss, that I would be able to host these using a company web server. However, I think for the purposes of this project, I think this is acceptable. And I haven't forgotten to talk about the star of the show, which is the inspector dataset, which is actually started out as a Excel spreadsheet that was provided to me by my employer. I geocoded the addresses of that file, which each inspector had an address, and I geocoded them using a geocoding plugin, which was very easy and convenient. Highly recommend. Finally, those were intersected with the New England buffer to filter out and show only the inspectors in the region. And then that file was saved as a GeoJSON file and then edited in Notepad++ to save as a JavaScript file. The fewer number of features in this dataset lends itself well to being drawn by the browser, which is referenced in the code. The final functionality that my map provides is the ability to search the address, the geocoding controller, which is a leaflet plugin. It allows the user to search for an address and zoom to that location the same way that many laypersons expect, thanks to Google Maps. And it means that anyone in our office can search an address and see nearby exposures, as well as the closest field inspector. It's implemented using a 30 lines of code or so that were pulled from this simple example. It's very, like I said, easy to implement. I only needed to make a few changes in order to make it a functional part of my web map. So I would highly recommend investigating that further for future web mapping projects, and I plan on using it in the future myself, just simply because it's a really easy way to add that type of functionality to a map. And thank you for watching my video demonstration, and I hope to create many more projects in the future. Thank you.